Okay, so this is like a note 7-9 part 2. We're going to just look at some longer log equations. So I've just rewritten your steps here for if x is inside the log, what we need to do. So looking at problem number 1, we first need to condense this to a single log. So based on this plus sign here, we know we're using the product property. So when we have a plus sign in between, that's going to turn to log base 12 of x times this x plus 1 equals 1. Okay, so in order to simplify this, I need to distribute that in. So this is going to be log base 12 of x squared plus x equals 1. Now, I should be technical and keep that in parentheses because we're taking the log of this whole big thing. So now isolate the log. Well, it already is. It's isolated. Make the coefficient 1. It's already 1. So now convert to an exponential. Okay, so when I convert this to an exponential, I've got 12 to the first equals this x squared plus x. So you'll notice in order to solve this, this is now quadratic. So none of the others were like this. This is quadratic. So like we did the square root equations, you need to get this in standard form, okay? So since I've got my x squared over here on this side and it's a positive 1, I'm just going to move over this 12. That's 12 to the first, so that's 12. So this is going to be 0 equals x squared plus x minus 12. And I can look at this guy and see that it's pretty easy to factor because if I made my chart, I would look for numbers that multiply to negative 12 but add to 1. Okay, and that is going to be 4 and negative 3. Okay, so I know that this factors to x plus 4, x minus 3. So therefore, when I set each of those equal to 0, x plus 4 equals 0, and x minus 3 equals 0. When I subtract 4 to move it to the other side, I get x equals negative 4 and x equals positive 3. So those would be my two answers. But just like when solving square root equations, you need to check for extraneous solutions. So hopefully by now, after doing 7-5, you have noticed that you cannot take the log of a negative number. So if I even were to try this, if I were to put in log, alpha window 5, if I were to put in log base 12 of negative 4, the calculator is going to scream at me, non-real answer, it's not possible. So if I say quit, it's going to give me error. Okay, so here, if you ever get a negative answer, that is going to be extraneous. You cannot take extraneous solution. You can't take the log of a negative number. So the only answer that should work is 3. And if I were to go back and plug this in, so log 12 of 3, because I'm plugging in 3 for x, plus log base 12 of x plus 1, so that's 3 plus 1. I'm just going to type it exactly as I see it. That should equal 1. Yay, it does. So that checks off. That means that 3 is your only solution. Okay, so let's look at one more example. Example number 2. So same basic setup. We need to first condense this to a single log. We've got a couple of things going on. We've got a minus sign in between, so that means quotient property. That's going to be a fraction. And this one's got this 2 out in front, so that needs to move up to the top to be an exponent. So we would have log base 2 of x, quantity x plus 3 squared, divided by 4, because that minus sign equals 2. Okay, so let's simplify this out before I start to look at anything else. So remember that x plus 3 squared means x plus 3 times x plus 3. So when I FOIL, that would give me x squared plus 6x plus 9, because my outer and my inner is going to be 3x, and 3x plus 3x is 6x. So let's rewrite log base 2 of this whole big thing, x squared plus 6x plus 9, all divided by 4 equals 2. Okay, so coefficient in front of my log is 1, and now I can go ahead and convert to an exponential. So that is going to be 2 squared equals this hot mess. Oh my goodness. Okay, so here 2 squared is the same thing as 4, and 4 is the same thing as 4 over 1. I wonder if you see what I'm getting at here. I'm making it a fraction. So all I've done, 2 squared is 4, and 4 is the same thing as 4 over 1. I'm making it a fraction so I can cross multiply. So when I cross multiply, I get 16 equals, 4 times 4 is 16. 1 times all this junk is just, all this stuff stays the same. Okay, so now again, I've got a quadratic, but I need to get it in standard form. In other words, I need this side to equal 0. So 0 equals x squared plus 6x. When I move that to the other side, it becomes a negative 16. So 9 minus 16 would be negative 7, or minus 7. So here, hopefully, again, let's look at these numbers. We would look for factors of negative 7 that add to 6. So if you think about it, that would be 7 and negative 1. So this factors to x plus 7, x minus 1, and then setting each of those equal to 0, I get x equals negative 7 and x equals positive 1. You cannot take the log of a negative number, so that is extraneous. Our only solution should be 1, but in order to check it, remember, I would go back in, do your alpha window, plug in, that had a 2 in front, 2 log base 2. We got x is 1, so let's plug in 1 plus 3 would be 4, minus log base 2 of 4, oops, and that should equal 2, so let's cross our fingers. Woo, so it equals 2. That answer checks out.